Hey guys, Mr. Fransky here. Going to talk about the ambiguous case for the law of sines today. The ambiguous case is the one where you have more than one possibility. So you're given some information about a triangle, and you don't know what the outcome is because there's perhaps more than one possible triangle that could be made. We also call it the naughty triangles because they're the SSA triangles. Again, remember, you can choose your maturity level as far as which direction you write that. I will always refer to it as SSA. So, getting into it, first of all, why are these triangles such a pain in the SSA? Well, if we think about it, the two triangles we dealt with law of sines so far are angle, angle, side, and angle, side, angle. Let's think about what those triangles look like. An angle, angle, side triangle might be something like this. So maybe you're given like 30 degrees, maybe this is like 50 degrees, and maybe this is like 6. So notice that with both of these, if I do an angle, side, angle, say something like this. I know this is like, let's say 40 degrees. This is maybe 120 degrees. Let's say this is like 5. Okay. With both of these, notice that you only have one angle missing. So you can find that angle for sure by just subtracting from 180. Here it would be 100 degrees, so these angles are not great, but that would be 100 degrees. Ooh. And here, let's see, we have 160, so this would be 20 degrees. Now, after you have all three angles, any triangle that has those three angles will be similar. So it's like you have all the angles fixed, and then you could make bigger triangles with those same angles, right? This one maybe would have the same angles as this guy. This one would maybe have the same angles as this guy. But this 5 fixes the triangle. It creates a unique triangle that can't be any different. And the issue with side-side angle is, okay, so these, like the side fixes it, and you have the three angles, so that's a unique triangle for both of these. The problem with side-side angle is that you don't have all three angles defined. All you have are 2. So if you have a side-side angle triangle, so let's say like, I don't know, maybe something like this. Okay, so let's say you know that this side length is 9, this side length is 6, and this angle over here is like 30 degrees. The problem with this is I don't have all three angles fixed. So I could take this 6, for example, and put it here instead. So if I put that 6 here, it creates a different triangle. So let's draw that over here. It would look like this. Oh, sorry, that 9 is fixed, so I can't do that. Let's try that again. So if the 9 is fixed down here, what I could do is I could swing this 6 in right to here. So basically what I'm doing is I'm making this 6 make a little arc here, like pretending it's like a radius of a circle and swinging it over to here to make a 6 there instead. So let's draw that triangle over here. So it'd be something like this. We have our 30 degrees still, but then our 6 is going to cut in like that instead of being over on the side. So we have two different triangles that could be made. And what happens is this angle up here, theta, is going to be different from this angle down here. And what you can figure out, so this is x right here, that would be the angle x right there. What you can figure out, sorry about that, is that this x is related to theta, because what I've created here is an isosceles triangle, because this side length is 6 and this side length is 6 as well. So this also is theta because they're base angles. It's a theorem dealing with isosceles triangles. And that means that this x right here is 180 minus theta. So what you do is basically you figure it out, and then you're able to find out what that angle is just by subtracting from 180. But there are two possible triangles that could be made that are side length of 6, side length of 9, and an angle of 30. Now notice that this, if we classify it, is given as a little s, big SA. Little side, big side, angle. And when that happens, it's also possible that no triangle is possible. So for example, I could make this 30 degrees bigger. Let's say we make it like 70 degrees. And this is still a length of 9, but let's make this like a length of 2. Well, I can still play with these angles, but no matter where I put that 2, there's no way I'm ever going to get over to this side. I can also make this one as long as I want, but this little side, big side angle just seems to be a pain, because I can't, it's possible that no triangle is possible. It's also possible that I have 2 different triangles. So it can really be a challenge if we have this side-side angle situation. And also, as we'll see, there are some times when there's only one triangle possible. So what that would look like is if you had, instead of little side, big side angle, you had big side, little side angle. So let's say instead I know that it's like 9, 6, 30 instead. So what that would look like would be like, this is a 6, this guy would be a 9, and then this guy would be our 30 degrees right here. So that would be a big side, little side angle. And the reason this is unique is because the longest side has to be across from the biggest angle. And so I know this 30 degree is not going to be my biggest angle. And so with that being across from the 9, that opposite side will have to be longer, and that fixes this angle as being the biggest angle. I can't swing this anywhere and keep this a 6 to be able to do that. So just a little bit of a description behind the theory of how these side-side angle triangles work. And now I just kind of want to bring you through how you deal with these things. So this may look complicated, but it's just a little flow chart that I think is useful for figuring this out. So the first thing that is important to do when you're dealing with any triangle really is to classify it. So classifying your triangle means that you're trying to figure out, is it ASA, is it SSA, which is the one we're talking about, is it angle side? Sorry, we already have that angle side we don't have. Okay, those are kind of the three we've talked about so far. Tomorrow, when we do law of cosines, we're going to talk about SSS and SAS. Okay, and really, all of these are simple to deal with except for SSA. If you have SSA, you have to see which kind of SSA do you have. If you have big side, little side, angle, that was the good one we saw in the last one. If that happens, that actually is going to lead to a single unique triangle. So if you have big side, little side, angle, that's going to be one unique triangle. And you'll figure it out using law of sines like we have before. And you'll have to finish that somehow with an inverse sine, because in this case, we're looking for an angle to start off with. We're not looking for a side like we were when we had the two angles before. So one unique triangle, and you'll use law of sines to find it. Law of sines to be able to find that triangle. Now, the tricky one is when you're giving little side, big side angle. If you're given little side, big side angle, you're going to try law of sines. Try law of sines. And if it doesn't work, like if you have a triangle like this, right, it's hard to even call that a triangle. But what'll happen is if you try law of sines on this, you'll get an error in your calculator. At some point in the process, you'll end up with sine of an angle. Let's say this is like AB, and then we're trying to create angle C up here, even though those are never going to connect. If you try to find the C angle, you're going to have sine of C. In this case, it would be sine of 70 over 2. 9 sine of 70 over 2. The deal with 9 sine of 70 over 2, I'm going to put that in my calculator real quick. 9 sine of 70 over 2 gives me 4.22. Well, that's bad, because I can't have the sine of an angle that's bigger than 1. If you do sine inverse of 4.22, you're going to get a domain error, or it'll say syntax error, or something like that. It'll say that it's not in the domain. You can't do sine inverse of 4.22. You can only do sine inverse of numbers between -1 and 1. So what happens is, at some point, if you get an error in your calculator, all you do is you write no possible triangle. Because that means that there's nothing that can be created with the dimensions they gave you. Okay, so like you cannot have a triangle, whoops, you cannot have a triangle that has like B is 2, side length A, that would be A is 2, and side length C is 9, and angle A is 70 degrees. It does not exist. There's no triangle that has those properties. So if that happens, you say no possible triangle and you're done. That's kind of the easy way out. If you try law of sines, doesn't work, then you know there's no possible triangle. But if it does work, if it works, that means that there are two triangles. So what you're going to do is you're going to do law of sines normally as you would. You'll find an angle, so you'll do a sine inverse, you'll get an angle. And so one of those triangles, you'll just use theta from law of sines. And that'll be what we call an acute triangle. It's acute because all the angles are acute, and also look how cute it is. Oh, it's so cute. So the acute triangle will have so a theta. Let's say a theta is right here. Let's say let's put it here. Okay, and then the other one that you're going to use, and we kind of talked about this in the last slide, it'll be 180 minus theta. So you'll do the same thing. The triangle will look a little bit different. So it might look something like this. Okay, so this might be swung in or it might be swung out, but this will be 180 minus theta. And then you'll solve it using that angle instead. Okay, so one you use theta from law of sines, and the other one you'll use 180 minus theta. And you'll solve these two triangles separately. So solve separately. Okay, so if you solve those two triangles separately, you'll have two separate triangles, and so basically two sets of answers. All right, let's try an example. So here we have triangle ABC. I always draw triangles the same, which is just fine. So we got A, B, C. And they tell us that side A is 7, side B is 6, and angle A is 26.3 degrees. Well, that's not a horrible drawing. The 7 should be a little longer maybe, but that's okay. So first we're going to classify our triangle. So we classify, it looks like we have big side, little side, angle. Big side, little side, angle. So let's go back to our flowchart. There we go. So big side, little side, angle, we're in luck here. That means we're going to have one unique triangle. All we do is use law of sines. So let's do that. So we have to use the 26.3 degrees in the 7. So I have sine of 26.3 degrees divided by 7 is equal to, this time I'm going to look for that angle. So I have sine of B divided by 6. Cross multiply. Actually, I'm just going to multiply by 6. So I'll have 6 sine of 26.3 degrees divided by 7 is equal to sine of B. Crunch that in my calculator. 6 sine of 26.3 degrees divided by 7. 26.3 divided by 7. I get 0.3797. So 0.3797 is sine of B. Now to find B, I'll have to do sine inverse of that value I just got. So 0.3797. And this will work because that's less than 1. So if I do sine inverse of that value, I get 22.31 degrees. So that'll go right here, 22.31 degrees. And now I can find the last angle by subtracting from 180. So first angle C, I'm going to do 180 minus 26.3 minus 22.31. And let's see what we get there. 180 minus 26.3 minus 22.31. It's going to be, wow, 131.39. This is 131.39. As you can see, my triangle is not drawn well, but that's okay. It's not a big deal. And now to find side length C over here, I'll do law of sines again. So I'll have sine, I'll probably use the 26.3 again, because I know that that one's right, divided by 7, equal to sine of 131.39 divided by little c. So c is going to be 7 sine of 131.39 divided by sine of 26.3. Crunch that real quick. So we do 7 sine of 131.39 divided by sine of 26.3. And I get 11.85. Makes sense. Longest sides across from the longest angle. And we're done. Because it was a big S, little s, a, we know that it's unique. So we know we're all done because it was unique. We had a big side, little side angle. So we know that we're done with that one. So now let's try one that's going to be a little bit more challenging. So we've got XYZ with 6, 7, and 30 degrees. So the way I usually do this is I draw my triangle and just put in XYZ. Okay, it might not be accurate, but it's going to be close enough. So we have, let's say that if this is Y, then that means this is going to be 30 degrees. And here we have our Z is 7 across from there, and this is 6. Okay, so this is a little side, big side angle triangle. And again, I'm going to emphasize the drawing of it. If you want to draw it to try to make it work, you can. Clearly the 6 I have here is longer than 7, but we have a little side, big side angle. So if it works out, we know we're going to have to do a second triangle. So little side, big side angle we've got going on here. So we're going to try law of sines because that is the first thing to do in our flow map here. We're going to try law of sines. So let's go ahead and give that a shot. So we'd have sine of 30 divided by 6 is equal to sine of Z divided by 7. Cross multiply, or just multiply by 7 here. So Z is going to end up being sine inverse of 7 sine 30 divided by 6. 7 sine 30 divided by 6 is 0.583. So that means that this should work out because that's less than 1. So if I do sine inverse of that value, I get 35.68 degrees. So now that I have this angle for angle Z, I can put it in here, but I need to remember that since this is a little s, big S, a triangle, and if I go back to my flow map here, I tried law of sines and it worked. So that means there's going to be 2 different triangles this is going to create. I'm going to use the theta that I found for one of them, and the other one I'm going to have to use 180 minus theta. So what I'm going to do is I'm going to put this on this triangle right here. So we got 35.68 right there, 35.68 degrees. And I'm also going to redraw that triangle on the next screen. And drawing this triangle, if you want to draw it accurately, it can be pretty tricky. But I'm going to try. I'm going to kind of rotate it and try to draw it a little bit differently. So what I'm going to do is I'm going to take this triangle, I'm going to bring the y down to this corner, and so I'm going to have the 6 and the 7 kind of on the two top parts of the triangle. So let's see if I can do that. So we have our 1, x, y, z, which is going to look like something like this, because we have two 30-degree angles, more or less. So I'm going to put the y on the bottom right and the z on the bottom left. And then I would have the x at the top. So this is 7, this is 6, and we just found out that we knew, let's see, that y was 30, and we know now that z is 35.68. So this is 30 degrees, this is 35.68 degrees. Okay, and real close with the numbers there at 6 and 7. So now, what I know is that there's a second triangle that involves not this angle, but 180 minus this angle. So what I'm going to do is I'm going to make that triangle. What's going to happen is this 6 is going to be kind of flipped out to the outside here. So it's going to look something like this. Oh, no, sorry. It's going to come to the inside. So I'm still going to have my 7 like this. What's going to happen now is that 6 is going to come down like this. Okay, so here's our 6. And this is going to come over this way. Okay, so we still have y over here is 30 degrees. So that's the same angle that we have right here. And this is still x over here, this is z. But now this angle right here for z, instead of being 35.68, is going to be 180 minus 35.68, because those both have the same sine value. That other triangle, I'm going to erase this, but if you put the 6 here, this was kind of the original triangle we had, and it was a little bit wider out the way that I drew it, but that would put the 35.68 right here. That's my theta. Since this is an isosceles triangle, this is also theta. So this angle right here, 180 minus 35.68. I'll put that into my calculator. Minus 35.68. I get 144.32. Okay, and I'm going to erase these parts. Now again, I don't really care if you can draw the triangle accurately. I think it's a good thing to think about. And just to kind of imagine, okay, what are these true triangles going to look like? Because it's weird to think this 6 has like swung onto the inside here. But really, like, if you just drew a second triangle that looked like this, and you said, okay, this is 6, this is 7, this is 30. Now I'm going to say that this angle is, what did I say, 144.32. Clearly it's not. But coming up with that value is a more important part. So as long as you have it correct, I don't really care how you draw your triangle. Okay? So now we're going to finish out this triangle. So I can find the last angle, angle x over here, by subtracting everything from 180. So I'm going to do 180 minus 30 minus 35.68. That gives me 114.32. So this guy right here is 114.32 degrees. And then I'll find my last side by using law of sines again. So I'll have sine of, let's use 30. Over 6 is equal to sine of 114.32, that's a 2, divided by x, little x right over here. And if we cross multiply and then divide, we'll have x is 6 sine 114 divided, 0.32, excuse me, divided by sine 30. Put that in my calculator, 6 sine of 114.32 divided by sine of 30. And I get 10.935. So this is 10.935. Again, really weird the way that this is drawn, but as long as you get the numbers, that's kind of the important piece there. So let's put those here. This was 10.935. And this angle up top was 114.32. Okay, and you'll notice on like the packet, or when we have our assessment on this, you'll have slots to kind of put these things in. So you'll write each of those pieces where they belong. I like to have them in the triangle, though. It's just a nice visual for me. So now over here, we solve this triangle separately. So we have 144.32 and 30. This is going to be a very small angle up in the corner here. 144.32 plus 30 is 174.32. So do 180 minus 74.32 gives me 174.32 gives me 5.68 degrees. So very small, 5.68 degrees. Now to find our last side x down here, we're going to use law of sines again. So we have sine of, let's use the 30 over 6 is equal to sine of 5.68 divided by x. So x will be 6 sine of 5.68 degrees divided by sine of 30 degrees. 6 sine 5.68 divided by sine of 30. Short side, good, 1.18. We'll take our x away there and put it there, 1.18. And now we have solved both of these triangles. So, ambiguous case, little side, big side angle. Just remember that you either get an error, and then there's no triangle, or you get an answer, and then there are two triangles, and for the second triangle, you're going to use 180 minus theta, which is how we got the 144.32 right there. So, hopefully this made a little bit of sense to you. If you have any more questions, as always, you can send me a text on Remind, or come on in and talk to me. Good luck. Love you guys. Have a great day.